Hello guys, this is Rakesh from Bodhee Prep. In this video, we'll be discussing in detail what are Surds and what kind of question appear from Surds in CAT and CAT-like exams. At the end of, after understanding the concept, at the end of this video, we'll also be taking CAT-like question also. How do we solve that questions, right? And the basic idea about the numbers which we have done till now from the previous videos, that too will also be used, right? In fact, I have touched the Surds very briefly when we discuss about the irrational numbers, because all sets are actually irrational numbers, right? So let us develop the idea to understand what is sets and how do we understand it. And usually the questions appear are all about the simplification of the same. So we'll also be understanding the tools by using which we'll be simplifying it, right? We'll be using laws of indices a lot, right? So in the last videos, we know that if I have any number, say 4, and if I take a square of it, we all know that this is nothing but 4 is multiplied by 2 times. So we'll be getting 16, right? So we may skip this process because we already know that 4 is square. 4 after squaring 4 will be getting 16, which is a perfect square, right? Similarly, 4 to the power 1 is nothing but 4 itself. 4 to the power 0 is 1, right? 4 to the power negative number, we know that this can be simplified or can be written as reciprocal, or 1 over the number, 1 over the positive power. For example, 4 to the power minus 5 is nothing but what? 1 over 4 to the power 5. I hope this much you can recall, right? Now, what about here the numbers are positive, here the number is negative, here the number is 0 also, right? But what about if the power is fraction? For example, how do we comprehend 4 to the power 1 by 2? Let us see that, right? Let us do that. 4 to the power 1 by 2. How do we get 2? We all know that. Many of you might be knowing that this is equal to 2, but how? So what we can do is that let us assume that this is some value x, right? So what I'm doing is that I'm just observing that the power is half, and if half is added to half, we'll be getting 1, right? So I'm targeting to get something like this. So what I can do is that if I have 4 to the power 1 by 2, and if I multiply it again by 4 to the power 1 by 2, right? This is what I have imagined, that if this would happen, then the power will add up, and that will give it to 1. Now this is nothing but equal to what? Now this is actually x. This is also equal to x, correct? Because I have assumed that this is equal to x. Now 4 to the power half into 4 to the power half. So now I can apply the laws of indices, which says that a to the power m into a to the power n is nothing but what? A to the power m plus n. Here both a and m are, both m and n are equal, and a is equal to 4. So here I can write it as 4 to the power 1 by 2 plus 1 by 2, which effectively is nothing but 4 to the power 1 or equal to 4. So clearly what I have done is that I have manipulated it to get the value which is very much comprehensible till now. So this is nothing but x into x, which is equal to 4. Now it is simple to break the value of 4 as 2 into 2. So here x into x is equal to 2 into 2. So just by simple comparison, I can say that each of these value of x is nothing but equal to 2. So the value of x is 2. That simply means that 4 to the power half is equal to 2. Now some of you might be wondering, sir, why only 2? Can't we take minus 2? Because I need 4 which should be product of two same numbers, So I could have taken minus 2 into minus 2 also. That is also a valid solution. So here the value of x would have two different possibilities, which is either plus 2 or minus 2. Both are part of the solution. Or I can say that 4 to the power 1 by 2 is nothing but equal to 2, or it could be minus 2 also, depending upon what we are looking for. In most of the cases, we look for the positive number, right? So unless we require the negative numbers, we will be avoiding henceforth. We'll be focusing primarily on getting the positive number. But please remember that the corresponding negative numbers are also the solutions, right? So as and when required, mostly it is required in algebra. So we'll be using that. I hope this is clear, right? So is there any other way wherein I can represent this? Yes, in the video of irrational number, I told you that 4 to the power 1 by 2 can be written as under root of 4. So this is also a different way of writing 4 to the power 1 by 2. Now what do I call this? We call this as finding the square root square root of the number. So this sign signifies the root. This sign signifies the root, right? For example, 9 to the power 1 by 2 is effectively is nothing but square root of 9. We all know that 9 is nothing but what? 3 into 3 or 3 square, right? Or it could be minus 3 to minus 3 also. So on solving, we'll be getting the value as to be plus 3 or minus 3. So we have both the possibility, plus 3 or minus 3. Usually when we ignore the plus sign, whenever the number is written, like for example, here it is 4, it is assumed that this is plus 4, right? So 9 to the power half is under root of 9, which is nothing but plus 3 or minus 3. So in general, if I have a number a whose power is 1 by n, this is known as, or this is written as this way. We call this as nth root of a. So this sentence or this phrase is very important. So whenever I say the root of a, so it is actually means square root of a, because usually this is silent. Whenever we just say root, it simply means square root. But apart from square root, if I have to name it, then I have to name that particular number of root. For example, a to the power, or say 4 to the power 1 by 3. This will be written as this way. We call it as cube root of 4. We call it as cube root of 4. Right? So what is square root of 4? The power would be half. What is cube root of anything? The power has to be 1 by 3. Correct? And let me just rub everything. And say fourth root would be what? Under root of fourth root of say 7. So we will be calling it as fourth root of 7. Right? We can have fifth root. We can have any number of roots. Right? So I hope you have understood the sign. What is the meaning of the root, word root, right? And how they are associated with the power as fraction, right? And we can apply the laws of indices, which we have already learned, to simplify them, right? Now, if I take, say, cube root of 64, what is the value of it? We have seen that under root of 4 is equal to 2. So what is cube root of 64? So again, what we can do is that we can write it as 64 to the power 1 by 3. We can write interchangeably. Now, I know that 64 is some power of 4 or some power of 2, right? We can prime factorize 64. We can write it as, if I want to prime factorize it, what we'll be doing is that it will be 2 32 times, then 2 16 times, then 2 again 8 times, then 2 4 times, then 2 2 times, then 2 1 time. So the number of times 2 is appearing is 6. So what I can write it as, this is 2 into 2 into 2 into 2 into 2 into 2, which to the power 1 by 3. Now this is 2 multiplied how many times? 6 times. So we can write it as 2 to the power 6 whole to the power 1 by 3. Now we can apply laws of indices, which say that a to the power m whole to the power n is nothing but a to the power m into n. So we can write it as 2 to the power 6 into 1 by 3, which comes out to be 2 to the power 2 or is equal to 4. So this effectively is equal to 4, right? This is the most detailed way of getting the value as 4. Apart from 2, what we could have done is that we would have written 64 is nothing but 4 cube. So 64 to the power 1 by 3 would have been 4 to the power 3, 1 by 3. On simplification, you'll be getting 4 straight away, right? But how you are writing 4 and why there will be 4, you'll be getting the idea by applying or by using this prime factorization. I hope now you have understood clearly what is this, the meaning of roots, cube root, square root, etc., etc. Now let us move to the next thing, which is understanding the sign. So under root of, so what is surds? Now let us define surds. So what is surds? So surds is actually an irrational number which are in the form of a like this, nth root of b, where a and b both individually are rational number, right? A and b are rational number, and we call this sign as the radical sign, right? Just remember the name, that this sign is called radical sign. It could be any number, right? Now we have found that under root of 9 is nothing but plus 3 or minus 3. What about if the number is negative inside the root? Can we have any two numbers whose product is -9? Both the number has to be the same, right? In case of 9, we know that this is possible because this can be written as +3 into +3, and it can also be written as -3 into -3. But in case of -9, since it is a negative number, there is no way you can think, or what you can do is that you can just pause the video and try to think about it, right? Try to think about two same number. Both the number has to be the same, right? None of don't take two different numbers. Try to take two same number and figure out whether their multiplication is -9 or not. I'm sure you will never be able to find it. Why so? Because there are no such number wherein the product is negative. No such number in the sense, no two same number where the product is negative. So under root of -9, I have written it, but is it comprehensible? Can I simplify it? The answer is no, right? Such kind of numbers are called imaginary numbers, right? Now, imaginary numbers are beyond the scope of any MBA entrance exams. So just for the introduction purpose, that what are imaginary numbers? Those are the numbers wherein the negative number is under the radical sign. The negative number is under the radical sign. Such numbers are called imaginary numbers. So since this is beyond the scope of CAT, let us just leave it here itself. I believe that I'll be making a small video exclusively on imaginary number to understand the fundamentals of it. But for the time being, you can safely ignore it. So from here, we have understood that in our scope, any sign within this has to be a positive number. This has to be a positive number, right? Next, let's move to some useful rules. These rules we have already done in the previous class, but since we'll be using it extensively, so let us try it. If I have under root of a into b, I can safely write it as under root of a into under root of b. Correct? If I have, say, under root of a divided by under root of b, I can safely write it as under root of a over b. If I have a under root of b plus c under root of b, so what is happening is that this is also third, this is also third. The under root portion is same, right? Other than that, a and c are different. So it can clearly be written as a plus c multiplied by under root of b, right? For example, if I have 2 root of 3 and I want to add it with 7 root of 3, then we can see that root of 3 is common. So that can be taken separately, and 2 and 7 will be added. So it will be 2 plus 7 root of 3. Similarly, 5 root of 2 minus 2 root of 2. Again, root of 2 is same, so we can write it as 5 minus 2 root of 2. So whether it is plus sign or minus sign, it doesn't matter. This will work this way. But if 5 root of 3 is given and we are adding with, say, 4 root of 5, then this we can't add. They will remain as it is. Why so? Because the under root portion is not same. The under root portion is not same, so we can't do that, right? So these are the simple rules. If any rules are, I'll be using it for solving any question, then and there itself, I'll be discussing that rules. So let us move to some questions, some basic questions, right? So what I have done is that I want to find the simplified way of under root of 8. Very simple thing. What I should be doing here. I know that 8 can be written as under root of 4 into 2, right? Why I'm writing so, you'll be understanding in some time. This can be further written as under root of 4 into under root of 2, right? Now we know that under root of 4 is nothing but equal to 2. Root of 2 will remain root of 2. So we have simplified under root of 8 as 2 into root of 2. You might be wondering, sir, why you have taken 4 into 2? Why not 2 into 2 into 2? I could have done that also, but I'm just skipping one particular step. The reason being is that we already know that what are perfect squares. We already know what are perfect squares. Now the thing is that if any number is a perfect square, and if you take the root of it, square root of it, you will be getting a rational number for sure. You'll be getting a positive integer, in fact, I'll say. For example, 4 is a perfect square, so under root of 4 is what? 2. 9 is another perfect square. This is equal to what? 3. Next number is 16. The under root of 16, you will find that this is equal to 4. So whenever there is a perfect square and there is a square root sign over it, we will definitely be getting a integral value or positive integral value. Correct? This, because of the same reason I have done this, that under root of 8, I know that 8 is nothing but a product of a perfect square, which is 4 into the rest of the residual number, that is 2. So I'm just breaking it into that portion, right? For example, I need to find, or I need to just simplify under root of 72. I know that 72, the closest perfect square, which is close to 72 but less than 72, is what? 36, right? 6 square is 36, 7 square is 49, correct? Then, sorry, not the closest. We have to find such that it should be the factor also. That perfect square should also be the factor of 72. So 72, if I want to find, then 36, 72 divided by, on prime factorization, we'll be getting 36. So this 36, we can observe that this is a perfect square. So best way is to write this as 2 into 36. We can write it. Why I'm doing so? Because I have got a perfect square. Now this can further be written as root of 2 into root of 36. This root of 36 is nothing but equal to what? 6 multiplied by root of 2. So this is the simplified way of this. So we should be very comfortable with converting this into this and also converting this back to this, right? For example, what is 2 root of 5? 2 is outside the root. 2 is outside the root. I want that 2 should get inside the root portion. So obviously 2 is coming outside the root. That means before coming outside the root, inside the root, it was a square of something. It was a perfect square. Square of something what? It should have been the square of 2. Then only we can say that 4 would have become 2. Right? So root of 2 root of 5 is nothing but under root of 4 root 5, which is equal to under root of 20. Right? Or you can understand this way also. If this is getting inside the square root, what we can do is that we can write it as 2 is going inside, so it should go to square. Right? Then only if this is coming out of this under root portion, it will only be coming out as 2 multiplied by 5. So again, you'll be getting 20. This is very important. So let us do one more, some few more practice. What is 3 root of 2? 3 is coming outside. Inside, it should be 3 square into 2, which comes out to be 9 into 2, which comes out to be root of 18. Right? What is under root of, say, let me take a number 24. Right? So 24 can be written as 2 into 12. It can also be written as 4 into 6. 4 is a perfect square, which can be written as 2 square into 6. So this will come out as 2 outside and under root portion will only contain 6. So I hope you are getting connection. This is very simple, but I just want to ensure that all of you should be comfortable in doing this, right? Let us take one more example. Can we have a number, say 48? Now 48, we all know that this is nothing but 4 into 12. 4 into 12. Further, 12 also contain one more 4. So we can write it as 4 into 4 into 3. Each of this 4 will come out as 2. Why so? Because each of this 4 is nothing but 2 square into 2 square into 3. So each of this as a pair will come out only once, and within the radical sign only 3 will remain. So which comes out to be 4 root of 3. Right? So what effectively we do is that we prime factorize the thing and we make the pair. So in your school days, what we have studied is that prime factorize this. So on prime factorization, you'll be getting this is nothing but 2 into 2 into 2 into 2 into 3. And then you make the pair. Why are you making pair? Because you want the perfect square to be formed. And every time a perfect square is formed, a number will come out of the radical sign, right? So for each of the pair, you will be taking only one number. This is a pair of 2, so you'll be getting only 1 2 outside. This is a pair of 2, you'll be getting only one number outside. And 3 is not able to make the pair, so 3 will remain inside the radical sign. So overall, the answer would be 4 root of 3. So this is the best way of doing so, right? But practically what I suggest is that you just pick the perfect square in which or the perfect square which is the factor of the given numbers. So if you do this, then each of these perfect square will come out, or the pair will come out, or you can say that if there is a 4, you'll be getting 2 outside. If there is a 4, you'll be getting 2 outside. And if a number is left, which is not a perfect square, it will remain inside the radical sign. Or what you can do is that you can use this prime factorization. So let us do one or more example for prime factorization. If I want to get under root of 72, what I should be doing? I should prime factorize 72. So prime factorization of 72 is what? 72 to 36, then 2 it would be 18, then 2 it would be 9, correct? Then it would be 3 times, then 3 it would be 1 times. So 2 is coming 3 times, 3 is coming 2 times. So we are getting a pair of 2, we are getting a pair of 3. So obviously this would be 2. From here we'll be getting 3, and this 2 is unable to make a pair, so it will remain as root of 3. So this will be getting it as 6 root of 2. You can check. We just did, right? Okay, so enough of the practice is done for this, right? Now next thing is, let us take an example to use this roots. Root of 5 when multiplied by root of 15, I want to simplify it. What I see here is that this root of 15, this root of 15 is also a multiple of 5. So we can write it as root of 5 into root of 5 into 3. We can further write it as this is root of 5 into this portion can be written as root of 5 into root of 3. These two together will become what? 5. Yes or no? These two together will become 5. We can prove it also because this is nothing but what? Root of 5 into root of 5 is 5 to the power 1 by 2 into 5 to the power 1 by 2, which is equal to what? 5 1 by 2 plus 1 by 2, which is equal to 5 to the power 1, which is nothing but 5. So if two under root portion, they are multiplied, overall the radical sign get vanished. Okay, we can make a thumb rule, right? So this become 5 and this root 3 will remain as it. Right guys? Fine. But if I want to do 4 plus 9, I can't do like this. I can't do like this. Right? Because 4 plus 9 is 13. Here this is 2 and here this is 3, which will make it what? 5. And we know that 13 and 5 are not, under root 13 and 5 is not equal. Because 5 square is not equal to 13. 5 square is equal to 25. So if there is a plus sign, we don't have to just say that this under root sign will be written this. This is a blunder. Only when they are multiplication or division we have to do. For plus sign or minus sign, we have not to do. We should not be doing that. Right? Okay. So let's do one more example to make it understand. Now what you can do there, I'm just giving an example. Pause the video, take a minute, simplify it, and then compare your answer. What is the simplified way of 400 into under root of 90? Just pause the video and do it on your own. Okay, I hope you have done it. Of course, by prime factorization you can do it, but we have to do it quickly. So what we should be doing is that we should be looking for perfect square in which that perfect square becomes the factor of it. Clearly, it shows that this is 400. Both 4 and 100 are perfect square. So can I write this as 4 into 100? Similarly, 9 is also a perfect square. So I can write it as 9 into 10. This becomes what? Under root of 4 into under root of 100. This further can be written as under root of 9 into under root of 10. Each one of them, this will become 2, this will become 10, this will become 3, and this will remain as under root of 10. So we'll be getting it at 60 under root of 10. The simplest way of doing this. Prime factorization way will also give you the same answer, but the process will be lengthy because the number are very large. Getting it? So that's why look for the factor which is a perfect square. Okay. Another example, do this. Under root of 2000 divided by under root of 50. Pause the video and please solve. Simplify it. Okay, let's process. So can I write this as under root of 2000 divided by 50? I'm just using the root. Under root of a or under root of b is nothing but whole under root of a over b. This will simplify it. So I'm getting under root of 40. Again, I can write it as under root of 4 into under root of 10, right? Because it is 4 into 10. This is nothing but 2 root of 10. This is the simplification of this. Correct? Okay. Now let's move to some other very interesting thing, which are, if I have number 1 plus root of 3, this is a surd, right? And I'm multiplying it with 2 minus under root of 2, right? Both are different looking. So definitely what we can do is that we have to multiply 1 with 2, so I'll be getting 2. We have to multiply 1 with minus of root 2, so I'll be getting minus of root 2. Then we have to multiply this, so we'll be getting plus 2 root of 3. Then we have to multiply this, so we'll be getting root of 3 into root of 2, which is nothing but 2 minus root of 2 plus 2 root of 3 plus this together we can write it as under root of 3 into 2, which is nothing but under root of 6. Right? Nothing is common, as you can see that. This is not carrying any kind of under root. This is only under root of 2. There is nowhere wherein we have only under root of 2. This is under root of 3. This is under root of 6. So this will remain as it is. There is no further simplification we can do. Right? But instead, 1 plus root 3, instead of multiplying this, had I multiplied with this, what we would have got? Let's see. Let's do the process. 1 is multiplied with 1. 1 is multiplied with root 3. Root 3 is multiplied with root 3, so it will be plus of root 3. Root 3 is multiplied with root 3, so it will become 3. Two same root kind of thing, they are multiplying, so root radical sign get vanished. This, we can see that this get cancelled. Now there is nothing which is a term having a radical sign. And we are getting 1, sorry, this will be minus, guys, right? This will be minus. This is root of 3 minus of root of 3. So 1 minus of root 3 will become minus of 2. I'm getting a rational number. Right? These are both irrational number. I'm getting a rational number. So it's not like that two irrational numbers are multiplied, so we'll only be getting irrational number. We may get irrational number also. So what is the difference here? What happened here is that here we can see that the numbers are same. The only in this case and in this case, the sign is different. Here, if it is a plus sign, I have taken the minus sign. Right? Why so? Because we know that a minus b, when multiplied with a plus b, I get a square minus b square. And if any one of them is under root, then square makes it a rational number, right? For example, under root of 2 whole square will make it 2. Correct? So, if I have a irrational number 1 plus root 3 and I'm multiplying with 1 minus root of 3, I will also always be getting a rational number. So, this is called conjugate. This is called conjugate of this. This is called conjugate of this. So if any irrational number a is multiplied with its conjugate, we will be getting a rational number. Right? We use this formula for rationalizing the denominator. Right? If you remember, we have done the rationalization of this. How? The denominator is irrational number. Surds is an irrational number. So what we have done is that we have multiplied this. Why we want to multiply the same number? Because we don't want to change the value of it, right? Otherwise it will become a different number. But at the same time, I want a rational number in the denominator. So this is a plus b, so I have taken a minus b, so that I can apply the logic of a square minus b square. Numerator will remain root of 2 minus 1. This will become what? Root of 2 multiplied by root of 2, which will be 2 itself. Right? This is what it will happen. This is a, this is b, this is a, this is b, then this is a square, right? What is a square? What is a square here? A square is nothing but root of 2 whole square, which is 2. What is b square? 1. 1 square is 1 itself. So this will become root of 2 minus 1 over 1. Here we can see that this is equal to this, but in this case, the denominator is irrational. In this case, the denominator is rational. The value will be same. Right? So this is all about surds. Now, as I told you that in this video, we'll be solving one cat-like question, right? So let's see that how do we solve a cat-like question. So I have to make a couple of more examples before I come to the cat-like question. So I have an example of, say, let me just take that example itself. I have an example of what will be the square of this. So this is a plus b whole square. We know that a plus b whole square is equal to a square plus 2ab plus of b square. Let us assume that this is a and this is b. So 2 square is this plus 2 into root of 5 plus root of 5 whole square. Which further simplification, this is 4 plus 4 root of 5 plus of 5, which comes out to be 9 plus 4 root of 5. Let me just write it clearly. This is 4 plus 5 will make it 9 and this will remain as it is. So 9 plus 4 root of 5. So from this, we can easily get this because we have such kind of expansion available. My question is different. My question is that, can you do the reverse engineering? When I say reverse engineering, what do I mean? I mean to say that if I haven't given this and I would have given that the value of x is 9 plus 4 root of 5 and I want you to find under root of x. That means I want to find the under root of this, right? So let us see that what is the process. The under root of this would be this, right? Because if I have, say, this is actually equal to what? 2 plus root of 5 whole square, no? Right? So under root of x would be what? Under root of this. So this should become 2 plus root of 5. But how to get 2 plus root of 5? If I don't know, if I have given only this term and we have to find the square root of it, how do I get 2 plus root of 5? So that is what we have to do. So let us see. So 9 plus 4 root of 5 under root of this. We can easily assume that this is a irrational number. Under root of it should also be an irrational number. This having a 2 terms and a plus sign between them. So let us assume that this should be somewhere, something like this. Right? X and y are rational number. It should be under root of x plus under root of y. Now, I want to get rid of this under root portion. So squaring both the sides. So on squaring both the side, of course, the under root portion will get vanished. And this will be under root of x plus under root of y whole square. Right? This is a plus b whole square. Under root of x whole square is x. Under root of y whole square is y. Plus 2 times of under root of x into under root of y will make it this. This is 9 plus 4 root of 5. Clearly, we can see that these two together should be equal to 9. This portion should be equal to this much. We can easily assume that. So x plus y, the value is 9 and 2 root of xy is 4 root of 2. So we can say that under root of xy should be equal to 2 root of 5. Right? I want that 2 should get inside. So it should become 2 square, which is 4 into 5. Getting it? Now just compare. If I take the value of x to be 4 and the value of y to be 5. X to be 4 and the value of y to be 5. Am I getting 9? Yes, I'm getting it. This we can just do by observation. We can just do by observation. So we can see that the assumption of x is equal to 4 and y is equal to 5 is satisfying both the equation. So we have identified the value of x and y. So obviously this would be equal to what? Under root of 4 plus under root of 5. Under root of 4 is what? 2, right? And this will remain under root of 5. So you can see that. You can just go a couple of minutes back to this video. You'll see that this was the question. I wanted the square of it. So we got this. So obviously under root of that square should become under root of this. So this is a reverse process. This is what CAT has asked a couple of times, right? So there is one homework which you have to do. You have to find under root of 5 plus 2 root of 6. Okay, this is one question, so don't take it as a homework. Pause the video, do it now. Okay, let's see. Again, what I'll do is that I'll assume under root of x plus under root of y. Squaring both the side, I'll be getting 5 plus 2 root of 6, which is equal to what? X plus y plus 2 root xy. Right? The same thing I have done here. These two together, x plus y should be equal to 5. Correct? And under root of xy is equal to 6. Under root of 6. So can I say the value of x into y should be equal to 6? A simple assumption that 2 and 3 is matching with this equation also. My assumption is matching with the previous equation. That means my assumption is the correct solution. So the value of x has to be 2 and the value of y has to be 3. So we can say that under root of 5 plus 2 under root of 6 is nothing but under root of 2 plus under root of 3. Which is the value of x and which is the value of y, it doesn't matter, because even if I have written it like this, it doesn't make any change. So this is all about Surds. I hope you have enjoyed this video. Please do go to the basic material on the same topic and solve some more examples. Apply these rules, but do not forget to understand the concept before the application, right? I'll be back with next video. Thank you.